Today we would like to present our technology, our AI-empowered solution in response to the climate change, which is called AI-assisted smart space cooling approach with ultra-high cooling power. So to begin with, let's imagine ourselves in a very hot summer day. We became uncomfortable, we began to sweat. What do? We usually turn on the air conditioner to cool off our body. But the same air conditioner that cools off our body also produces carbon emission, as well with the refrigerant, which is very dangerous to the environment. These things will eventually contribute in increasing the global warming and eventually making the weather even hotter, and the cycle repeats. So in a view of this problem, that's why there's a Paris Agreement that limits the global carbon emission for about 2 tons yearly. But in Hong Kong itself, it's already 4.5 tons. It's already double. So as I mentioned earlier, the carbon emission is because of the excessive electricity usage by the air conditioner. In Hong Kong itself, the electricity is mostly consumed by the air conditioner. Now, if we don't take this matter seriously, the carbon emission produced by the use of air conditioner itself can increase the global warming up to 0.5 degrees Celsius in the next decades. Now, this 0.5 degrees Celsius might not be too big of a number, but it implies to increasing the global water scarcity by 5%, increase the homelessness of 10 million people, and destroy permafrost for about 2 million kilometers square. So in that case, we have come up with a solution called camel-fur-inspired passive sorbent cooler, or we can call it CPSC system. Now, before we dive into the CPSC system itself, let me briefly talk about the cooling system of a camel, because this CPSC system is inspired by a camel. So when camel is exposed to extremely hot weather, it does not use air conditioner to cool off its body. It uses its unique cooling system. So when the camel takes up the water itself it's stored in the blood cells. And then only when the camel is exposed to very extreme weather, hot weather, then the water inside the blood cells will evaporate and perform the evaporative cooling approach to the camel. Now, our CPSC system enables buildings and housings to adopt the same cooling system as the camel. It has 2 major components. The first one is PTFE membrane, and the second one is lithium chloride or superhydrophilic expanded graphite sorbent. The CPSC system captures the moisture of the water inside the CPSC system, and the lithium chloride and the superhydrophilic expanded graphite change this moisture into a liquid, which you can refer as the blood cells of the camels. And then the PTFE membrane, which you can refer as the camel fur, will inhibit this liquid to leak out of the CPSC system. And during the daytime, when the CPSC system exposed to very hot weather, then it will perform the evaporative cooling approach, that it can have a cooling power of more than 630 watt per meter square. And it can lower the room temperature up to 5 degrees Celsius. As you can see here, based on our prototype, indoor room temperature and outdoor room temperature with using the CPSC system, it has a difference. Now, our CPSC system is one product. The other one is the AI, because the previous existing product has a limitation, which is its cooling performance is truly based on how much the moisture is captured inside the CPSC system. So, because it does not connect it to any power source, it serves more like a battery. The first one is to perform the in-material moisture consumption control, making sure that the moisture inside the CPSC system is used efficiently. And the second one is adaptive system control, to make the CPSC system user-friendly, so not to make it too cold or even too hot to the user. Now, our CPSC system will use the use of CCTV camera for 2 main purposes. The first one is to detect what kind of activity the people does inside the room, and the second one is count the number of people inside the room. As you can see here in the video, the CCTV camera, the AI detects, and this with the temperature difference from the temperature sensor inside the room will become the input towards the reinforcement learning framework of the AI, and then the AI will perform the smart control. Here's a video simulation about our CPSC system with the AI. So this is the working principle that I just mentioned earlier. So during the daytime, it will perform the evaporative cooling approach. And as you can see here in the top left corner, the cooling power will be depending on how many people and what kind of activity it does inside the room. So based on our rough calculations and assumptions, our CPSC system can reduce 37 to 50% the use of air conditioner. So it is an important point that the use of CPSC system is not to replace air conditioner, but it is to use it together. It can reduce up to 37 and 50% of the use of electricity and hence the carbon emission. And here's the cost estimation of the use of our CPSC system based on also rough calculation, and it costs around 400 HKD for the lithium chloride, and we provide another substitute for the lithium chloride because for the market this may be too expensive for them. We also provide the calcium chloride, which costs a lot cheaper, but it has, of course, less cooling performance for about 10%. So in that case, if buildings around Hong Kong's and Greater China adopt the CPSC system, let's imagine how much carbon emission will be reduced, and hence it will positively contribute to the climate change. So in that case, let's make a world a better place with Team CityU. Thank you very much.
Why do you use camel fur? Because that's a mechanism for all like us. Humans use the same mechanism to cool ourselves down.
Because in the desert, the temperature is very high, and the temperature difference is quite large. But for our human, it's not that. Because in camel, it can store the water in their body first, and then evaporate the water as a sweat to cool themselves. And it is most significant for the camel, and it is the most largest. It is the largest difference between the people and the camels. So that's we use the camel.
It's very nice that you use evaporation of water to
Yes.
cool the environment down, but at the same time you're using condensation of water so that it can evaporate the next day. But condensation increases the temperature. So for a certain setting like this room, you initially increase the temperature because the water vapor condenses in the water, and that will require extra energy to cool it down, right? Do you get what I mean? During the daytime, you use evaporation which absorb the heat. The net result should be zero. So I'm wondering if there is net benefit in your whole process.
Actually, thank you for this question. In our system, the material can absorb the water all the time. But at night, because the temperature difference, it can absorb the water obviously and fast. But during daytime, it still can absorb the water, but it's not that obvious compared to the daytime. And the water is a recycling system. It can absorb the water to treat it as a liquid and then evaporate. But we can use the AI system to calculate how much the water amount needed in our system, and we can prepare for the amount materials.
I just want to ask about the AI. Sounds like you are using AI to try to inform the system. Why don't you just use thermostat? Why don't you just have a sensor of measuring temperature, the room temperature, so that inform the system to start activate? Why do you want to collect number of people? Because at the end of the day, we are in this room. What we feel is the temperature and the humidity of the environment. You can easily measure that. You don't need to measure me. You measure the room. I will feel that already. So what this extra AI is helping?
Thank you for your question. So for your first question about the AI part, let me briefly explain our ideas to you. So our idea is not denying the traditional control of the AI conditioning system. We are just trying to propose an alternative way of maintaining the control function. So for using AI, we have several reasons because of the advantages of AI. So firstly, as you can see that our material depends on the water moisture within itself. So the first target is that we'd like to minimize the water waste during the off-peak period, which, for example, like no people are in the room or the room is not in use. We do not want the fan speed to be too high so that the water will be easily wasted. So therefore, the first target is to minimize the water waste.